Welcome. So we're going to be writing the equations for functions given the derivative and initial condition. And these are going to be the second derivative. So we're given the first derivative, we're given the second derivative. So we have to first integrate to find the first derivative, and then we have to integrate again to find the original function. So our second derivative here is, there we go, is 12x dx. If we integrate, we'll have, and so this, by the way, is the first derivative. We'll have 12x, and then we have to increase the exponent by 1, right? So that would be to the second power. And we have to divide by the same thing. It's just the power rule. And then, of course, plus c, right? Because our constant would be lost when we took the derivative. So we'll simplify this. So the first derivative, plus or minus a constant, would be 6x squared plus c. To solve for c, we're going to have to plug in our initial condition. So it tells us right there, the first, when x is 0, the first derivative is 1. Right, so we'll substitute 1 for that first derivative, and we'll substitute 0 for x. So 6 times 0 squared plus c, well, that's just going to be 0, right? So 1 is going to be c. So that means that the first derivative, before we took the second derivative and lost the constant, the first derivative was 6x squared plus 1. All right, so now we're going to take that one and we're going to integrate it. We're going to integrate the first derivative. Oops, no, I wrote that. 6x squared plus 1. Okay, and so when we integrate, right, it's just going to be power rule again. Right, so we'll integrate the 6x squared, and we'll integrate the 1. So that's just the x there. All right, so when we integrate, this will increase by 1. So we have 6x cubed divided by 3. I'm running out of space here. Guess I wrote too big. Oops, come on, everybody move up. There we go. And then when we integrate the dx, that's going to be just 1. 1x. Right, because this is technically 1 dx, right? And so that exponent is that's 1x to the 0 power. We increase it by 1, that would be x to the first power. Of course, there's nothing to divide by because we'd be dividing by 1. And now plus c. All right, so and this is the original function that we're looking for. All right, so let's just reduce there. So that would be 2x cubed. My shadow keeps getting in the way, plus x plus c. And now we're going to use this initial condition to solve for c in the original function. So when x is 0, the whole function was equal to 2. So we'll replace f of x with 2, and we'll replace all the x's with zeros, and that's going to mean that, well, c is 2. And that means that our equation, so we can find the actual equation, what it really was before we took the derivative, was 2x cubed plus x plus 2. That's the original equation. So all you have to do, if you're given the second derivative, is to integrate and then solve using your initial condition for c, and then integrate again to find the first derivative, and again solve for your initial condition to solve for c, and that's your equation. That's all there is to it. I think I have one more example. All right, so, or maybe two. We have here the second derivative is x cubed minus 2x plus 1, and we're given the initial conditions for both the first derivative and the original function. All right, so we'll integrate x cubed minus 2x plus 1 dx. So we're going to integrate the x cubed. We'll integrate the 2x. And we'll integrate the 1. So that's going to give us, we'll increase by 1 and divide by the same thing. So x to the 4th divided by 4 minus 2x squared divided by 2 plus x plus the constant. And then we'll just reduce x to the 4th divided by 4 minus x squared plus x plus c. And that's our first derivative. Well, the family of functions, that's our first derivative. We have to solve for c to find our actual first derivative. And so we're given the initial condition here when x is 0, our function is equal to 1. So 1 equals 0 to the 4th divided by 4 minus 0 squared plus 0 plus c. You don't always get x being 0, but when you do, it makes it really easy to solve for c. And so our first derivative is 1/4 x to the 4th minus x squared plus x plus 1. And now if we integrate that, minus x squared plus x plus 1 dx. All right, so we're going to integrate x to the 4th divided by 4 and x squared and the x, and of course the 1. I don't really need to write 1, I can just put dx. Right? And getting back to the original function here. So we'll increase by 1, divide by the same thing. So this is going to be x to the 5th divided by 20, right? If I divide by 5, I already got a 4 down there, it would be divided by 20. Minus x cubed divided by 3 plus x squared divided by 2 plus x plus c. And I should have written a little smaller because now I have very little space to solve for my initial condition. Well, I'll just kind of extend the page a little bit. It's okay if you don't see the question anymore. Oh, there we go. I can still see the question. And we have 0, 0 as, well, won't take us long to solve for that, right? If we plug in 0, well, what could possibly C be? Can't imagine. Oops, that's supposed to be 0. Well, it seems like C is 0. And so that means our is just what we had before, except no c, because c was 0. So our original function is x to the 5th divided by 20 minus x cubed, 1/3 x cubed plus 1/2 x squared plus x, and that's it. That's all there is to it. Right? I might have one more example. I can't remember. Seemed to think there was one more. Yes, there was. All right, with a trig function, and I think this is the last one. Yes, that is. All right, so we want to integrate here. Second derivative is t minus cosine t. Right, so we have t minus cosine t dt. We'll integrate the t, and we'll integrate cosine t. Right, so we integrate t, that's just going to be t squared divided by 2. Of course, this is, since we're given our second derivative, this is our first derivative that we're finding. And then the derivative, the integral of cosine, whose derivative is cosine, that's sine. Derivative of sine is cosine. So that'd be minus, because there's a minus there, sine t plus c. All right, now we'll solve for c. I'm going to do that over here, where I have some space. So we're going to plug in 2 for our function and 0 for t. So we have minus sine 0 plus c. And these are both 0. So 2 is c. Oh, I've made this so difficult for us, huh? I should have made it a little harder, huh? Because I may not be so nice when I give you a question. I don't know, maybe. These really aren't that difficult. So our function, our derivative here, our first derivative is t squared divided by 2 minus sine t plus 2. All right, and so now we'll integrate to that one. All right, so the integral of t squared divided by 2 minus, dt minus, actually, I'll write it all as one equation first and then I'll just split it. Minus sine t plus 2 dt. All right, so we'll integrate. We're going to increase the exponent by 1 and divide by the same thing. So I've already got 2 in the denominator. So now if I divide by 3, I'm really dividing by 6. Right? Oh, actually, I was going to write it separately and then take the integral. Just to make sure everybody understands what we're doing. Sine, so we're just taking the integral of each of these terms. All right, so like I said, this is going to be t cubed divided by 6, right? Because you have 1/2, and then you're going to divide by 3, so that's like multiplying by 1/2 and 1/3. Okay, that's where that 6 comes in. It comes from. And then whose derivative is sine? Well, the derivative of cosine is sine, but negative sine. So we're going to have minus a negative cosine t. All right, you take the derivative of cosine, you get negative sine. There's a negative there, but it's outside the integral sign. So we're really going to have a minus a negative. So that's going to be a plus. And then we integrate 2 dt, that's going to be 2t, and then plus c. And this is the original function. I'm going to get rid of this over here. So I have room to write f of t. And so let's just nicey up that double negative there, make that plus cosine t plus 2t plus c. And now we have to solve for c. And I'm going to do that over here because I have no other space. So when x is 0, the function is equal to negative 2. So negative 2 equals 0 cubed divided by 6 plus cosine 0, and then plus 2 times 0 plus c. So we have negative 2 equals, well, we got 0. The only thing that's not a 0 in here besides the c is cosine 0, because that's 1. All right, so negative 2 equals 1 plus c. Just subtract 1 from both sides. Negative 3 is c, and that means our function really was t cubed divided by 6 plus cosine t plus 2t minus 3. And you can always check yourself on these ones, because now when you have this function, if you take the derivative, you should get the first derivative. And if you take the derivative again, you should get the second derivative. So you can always check your work to see if you get the same thing. Okay? So if we were to take the derivative here, I won't write it down, I'll just do it, just kind of say it. So derivative of t cubed divided by 6, the 3 would move in front. All right, so now that's going to be 3 over 6, that's going to be 1/2. Right, so 1/2 t squared, and that would be minus sine plus 2. And that's what we have over here, right? T squared divided by 2 minus sine t plus 2, because the minus 3 would be lost. All right, now if we took the derivative of t squared divided by 2, the 2 would move in front, and we would decrease by 1. So the 2 would cancel, so we'd have t. And the derivative of minus sine t would be minus cosine t, and the derivative of 2 is 0. So when we take the derivative of t squared divided by 2 minus sine t, we're going to get t plus cosine, t minus cosine t. And that's exactly what we have above. Right? So you can always check yourself by taking the derivative. That's one of the beauties of integrating, is you can always check yourself. And my cube there just looks way too big. There we go. And that's the end of this podcast. So thank you for watching, and I hope that I've made integrating when I'm given the second derivative and finding the original function, giving some initial conditions, very clear for you. All right? Have a great day. Thanks for watching. Bye.